Okay, so let's start with the next topic, that is statistics. Now, statistics is something which is very important to learn AI and ML, because unless you have a good understanding of statistics, you may find it difficult to write certain programs, particularly where statistical usage is there. So therefore, the understanding of statistics is very, very important. So let's try and understand that. So statistics is the discipline that concerns the collection, organization, analysis, interpretation and presentation of data in applying statistics to a scientific, industrial or social problem. Any problem that is there, you will see that it always has certain data, and that data needs to be organized, needs to be interpreted, needs to be presented, and all that is required. So statistics is the study of the collection, organization, analysis, interpretation and presentation of data. It deals with all aspects of this, and including the planning of data collection in terms of design of surveys and experiments. So what exactly we mean by statistics? Statistics is the science of collecting, organizing, presenting, analyzing and interpreting numerical data to assist in making more effective decisions, because decisions are to be taken and the basis of decision is going to be your data only. So in view of that, understanding of statistics is very important. Now, when analyzing data, it is possible to use one of the two statistical methods. Now, it may be descriptive statistics or inferential statistics. These are the two types of statistics. Now, when we talk about the descriptive statistics, it means that it can further be divided into two, that is measure of central tendency, and the second is measure of variability. Now, measure of central tendency includes mean, median, mode, etc., whereas measure of variability includes range, variance and dispersion. Similarly, inferential statistics is something which is very important. Why it is important? Because when you get the results in the form of a table or in the form of a chart or graph, etc., you have to interpret it, you have to infer it, and inference is to be derived only when you have a good knowledge of the statistics. So that is why inferential statistics becomes also very important. Now, descriptive statistics is the discipline of quantitatively describing the main features of a collection of information. The set of brief descriptive coefficients that summarizes a given data set, which can either be a representation of the entire population or a sample. Generally, in statistics, you would see that the entire data, the whole population is not considered. You always draw a sample and then you do your whatever manipulation that you want to do or calculation that you want to carry out, and then you put it to the entire population. That is how generally the procedure is, but it depends on the situation. Now, inferential statistics is a process of drawing information from sampled observation of a population and then making conclusions about the population. So you have to draw your conclusions because you have got the results. Now, to understand the results and draw your conclusion, that is what is important in the inferential statistics. So inferential statistics are used as test hypothesis and make estimations using sample data. Whereas descriptive statistics describes a sample, inferential statistics infer predictions about a larger population that this sample represents. So that is the basic difference between the descriptive and inferential statistics. Now, statistics is an objective way of interpreting a collection of observation, because that is how you can put it in more simple words. Types of statistics are under descriptive techniques, central tendency and variability, correlation techniques, differences with or between the groups, all that can be observed. And then in descriptive statistics used to summarize, they condense a group of scores. It includes measures of central tendency and measures of variability. So that is how you can understand as descriptive statistics. The central tendency scores mean, median, mode, etc. Mean means average. We all know that whenever you calculate your average, it is the mean only. Median means the midpoint of the total data set that you have. Mode is the most frequent occurrence of a particular number or in a data set. Variability scores means that standard deviation, variance, range of scores. So all that comes under the variability scores. Now, central tendency means that measures of central tendency means that what is that, how the graph has been created, which describes the average or common score of a group of scores. That means under that graph, which may be a bell type or whatever type of graph, how many data points are occurring. Common measures of central tendency include the mean, median and mode. That is how you can easily understand with the help of the mean, median, mode. The mean is the arithmetic mean, as we have already seen. The calculation of the mean is also very simple, both the number of scores and their values. The formula of the mean is very, again, simple. We all have done in our schools. Capital M is equal to sum of x divided by total number, that is n. And then you can calculate the average or mean. Like for example, 6 men in high serum cholesterol participated in a study to examine the effects of a diet on cholesterol. So you have these numbers, 6 numbers, and then you can determine the mean, which is very simple. Just add them together and whatever number of observations that you have, divide by that. So the median is the middle point of the ordered distribution at which an equal number of scores lies on each side of the your number. So that means it is something like the formula is median formula is equal to n plus 1 divided by 2. It is also known as 50th percentile or second quartile. And that is the way it is represented. Example, calculate the median of the following measurements for height: 71 inch, 73 inch, 74, 75, 72. Now suppose this is the number that you have. So calculate the median of that. You can place the scores in order and then see that which is the midpoint. And then to calculate the position of the median using the following formula, like MDN is equal to n plus 1 divided by 2. And when you do that, you will get that number as middle point, or maybe 73 in this case. So determine the value of the median by counting from either the highest side or the lower side, and until the desired score is reached. So that is how you can calculate the median. The mode is the most frequently occurring score. Which of the following score is the mode? Like you can see by observation, but since the numbers may be very big, then in that case it may be difficult for doing it manually. So you can definitely use a formula for that. Similarly, the another data set like this, as shown as 24964662282, etc. And what is the mode? 776655 and 4. So the distribution with a single mode is said to be unimodal. Now when you are calculating only one mode of that, it is known as unimodal or single mode. A distribution with more than one mode is said to be bimodal or trimodal, or in general it is known as multimodal. So measure of variability describes the extent of similarity or differences in a set of scores. These measures include the range, standard deviation and variance. Now this is how you can see the graphs that will appear when you draw the graph. The standard deviation, a measure of the variability or spread of a set of scores around the mean. Intuitively, the sum of the differences between each score and mean, known as the deviation scores, appears to be a good approach for measuring variability around the mean. So this is the formula for calculating the standard deviation, that is under the square root. Then within that you have the summation x minus x bar of the whole square and then divided by n minus 1. So you can calculate the standard deviation. Symbolically we can write this as it is shown, summation x minus capital M. Let's use the scores 1, 2, 6, 6 and 15, where m is equal to 6. So you can calculate the standard deviation with the help of this formula. Now let's calculate the sum of the deviation scores. Again, similarly you can calculate as it is depicted here in front of your screen. You can easily calculate the standard deviation. Now the variance in the square of the standard deviation that can be seen, it is used most commonly with more advanced statistical procedure such as regression analysis or analysis of variance, which is in short it is known as ANOVA, and the determination of the reliability of a test. Now the range is equal to the high score minus the low score in a distribution. So range is also sometimes very important and very useful, and you may need to use it in your program. So it is considered as an unstable measure of variability and can change drastically if extreme scores are introduced to the distribution. So this is how, as it is shown in the picture, you can see the range is from start to end. So that is the range. Provide an expected upper and lower limit for a statistic at a specific probability level, usually 95% or 99%. So that is known as confidence interval, because confidence interval is very important because it shows that to what degree of confidence that you have in this. Now confidence interval is dependent upon the sample size, homogeneity of values within the sample, and the level of confidence selected by the researcher. For example, a sample mean as an estimate of the population mean. A confidence interval provides a band within which the population mean is likely to fall, and that is where you need the confidence interval, because you cannot be 100% sure that exactly this number is going to be there. So that is why you will give a range between 95% to 100% or 90% to 95%. So that is what your confidence interval. That means you are confident that the result is going to fall between 90 to 95% or 95 to 100%. That is what the confidence interval means. The standard error is the variability of the sampling distribution of the statistic. Now correlation is again a very important and very useful technique available, and we will see how we can use it in artificial intelligence. So correlation indicates the extent to which two variables are related or associated. That is, the extent to which the direction and size of the deviations from the mean is there. That means there it may be, how it is correlated, how two variables are correlated, one variable with the other, whether one is going up, the other is going down, or both are rising, or both are going down, or whatever. So the relationship between the two variables is something which is very important, and that is what the correlation. So the direction and the size, etc., is important in this case, like you can see in this picture. And correlation is always depicted with the small r. So that when a line which you draw in a graph, if it is going upwards from your origin, that is point, then you can see that it is a positive correlation. When it is scattered like this in the second picture on top, you can say that it is scattered. So there is no relation. R is equal to 0 means then there is no relation, because it is not giving you any direction, any clue, in fact. Now similarly in the third picture, if you see R is equal to -1, that means it is going from top to bottom in the right side. Similarly on this bottom side, R is equal to plus 0.6, that means you can see that it is going from slightly away from the origin to the top side, right hand and the top side. Similarly on the last picture, you can see that it is going from top to bottom on the right side. So that is why it is negative. So these are the ways that you can easily understand that what is the relation and how the relation is going to be there. Now categories of statistical test, like parametric, there may be parametric test or non-parametric test, etc. Within parametric test, normal distribution or equal variances, independent observations. Then non-parametric test, like distribution free, distribution is not normal, and normal curve is skewness or kurtosis. We will discuss this also. Like here you can see this is a normal curve, which if you go back, you can see that a normal distribution is a normal distribution. That means it is very, very straight, standard kind of a distribution. That is why it is known as this is a skewness. Skewness means it is tilted towards the left side on the first graph, and in the right side you can see it is tilted towards the right side. So that is why it is known as skewness. It is skewed towards the left or skewed towards the right. That means that affinity is there either on the left side or on the right side, wherever it is going. So skewness is a measure of the extent to which a probability distribution of a real valued random variable leans to one side of the mean. So that is how the skewness can be easily understood. The skewness value can be positive or negative or even undefined. Kurtosis is the measure of the peakedness. That means how sharp the peak is. The sharper the peak, that means you can say that it is, the kurtosis is very, very high. If the peak is very flat, like you can see on the second graph, that means it is not very sharp. So the kurtosis is almost flat type. Now then there is an ordinal number. In set theory, an ordinal number or just ordinal is the order type of a well-ordered set. They are usually identified with hereditary transitive sets. So that is how you can say that it is an ordinal number, which definitely gives you a kind of a ordered, impression. Nominal numbers, sometimes called categorical numbers also, are numerals used for identification only. One needs to select the type of data is there, whether it is cardinal or ordinal or nominal. So that is how you can easily understand the difference between the type of data that you have. Deciles. Deciles means the data is ordered and divided into 10 parts. Decile means 10. So when it is divided into 10 parts, then you can say that it is a decile. Then cut points are called deciles. Similarly, percentiles. When the data is ordered and divided into 100 parts, then cut points are called percentiles. It may be 25th percentile or maybe 50th percentile or whatever. So that is how we understand, and it becomes easier for us. Then coefficient of variation. Now coefficient of variation is the standard deviation of data divided by its mean. It is usually expressed in percentage. Coefficient of variation is equal to sigma divided by r, that is your coefficient of correlation, multiplied by 100. So this is the way you can easily understand that coefficient of variation formula is equal to standard deviation divided by mean. So this completes the first part of the statistics, and all these are very fundamental, but then we must understand it, because this is the building block of your artificial intelligence or machine learning. So this concept we are going to use, not exactly we are going to use it in AI or ML, but definitely this concept will be very helpful to understand the AI ML. So thank you for this. We'll move over to the second part of statistics now. Thank you.